My name is Renato Bonetti. I worked with Bernex for 35 years, had different technical functions, R&D, product management, and development, all this kind of stuff. And on the end of my career, I was in charge of safety, health and environment.
My name is Christos Strakov. I'm working with this company for more than 21 years and start here as a process engineer, do also some product management, and now I'm head of R&D. My first touch with CVD was more than 25 years ago, and that's still quite exciting.
My name is Val Lieberman. I'm with Ionbond since 2011, so that makes it 14 years, almost to date. When I joined as a manager of engineering from the equipment side, and then I involved in segment management, meaning management of some of the product lines that we have in our company. My background is very, very technical, so for better or for worse, I started with CVD and still it's going strong.
My first contact with CVD was in 1971 in Neuchâtel. I was there in the Swiss Watch Research Laboratory and was involved in development of boron watchstones, little watchstones, it was not a coating deposition, it was CVD forming. This gave all these problems we had in this time with vacuum pumps, which needed liquid nitrogen traps, flow meters by hand, glass vaporizers. It was the heroic time of CVD when everything was new. And afterwards I joined this company to set up the coating center in Cleveland, Ohio.
My first experience with CVD was something like 2001 in the university, where I started to do quite a lot of research. Everything was fully still manual, flexible. That's what the research in the university it is. And then I joined the Ionbond company 2004, seeing already a good established on the market name and brand Bernex for CVD technology. Everything fully automated, of course. Still problems with the pump still exist. That still will be a main issue for the technology. But for me, this was, of course, like a quantum jump from, let's say, university research to really established company on the market.
Well, I have a confession to make that, it was not my childhood dream to become a CVD process engineer or a CVD engineer, but it more like happened so, and I have another confession to make, no regrets. So basically it was my PhD work which went in the direction of coatings, and CVD was one of the technologies that was present, and so I was stuck with this. And again, that was, I've been doing this age-wise. I think I'm in between Renato and Christo, so I know a little bit more about the non-manual operation, but still it's more in the Renato direction. So again, that was my first encounter with CVD. Probably a little bit different because I use different precursors, plasma and so on and so on. But in general, it is the same. It is the same ups and downs of development, successes, setbacks, and so on and so on.
Well, for me, it was the development of the ADLC. It came down with temperature. We did no longer need chlorides. We had nice precursors, not reactive. Of course, it was high vacuum, it was plasma, but it opened a broad field of applications. I think this was the main lead. Then minor things, especially cutting tool regarding, was the moderate temperature CVD, and then also the development of the aluminas without the edge build-up, dock boning, and also the different modification, which was really a big step ahead, challenging in technology, but also bringing big success in applications.
If we look back to, let's say, some years, then main characteristic of CVD was always high temperature. So the really big jump was when family Bonetti developed the moderate temperature CVD below, let's say, even 900, talking about 850, 860 degrees C. And that's, in that time, opened quite a lot of broadening possibility for different substrates, and of course enhanced quite a lot of possibility to coat on a different way cutting tools.
Well, it's difficult for me to add something because there were, of course, breakthroughs, and I just appreciate Renato being very modest in terms of mentioning moderate temperature CVD as not the first one, but this is one of the biggest achievement that Renato and Bernex company came up with quite some time ago, because it expanded the markets, it improved the quality of the coating, so it was a very, very important development in CVD. Of course, DLC, plasma enhanced CVD processes, that is another offspring of the classical CVD, along with processes like HF CVD to produce polycrystalline diamond, or ALD, atomic layer deposition, is also an offshoot of the classical CVD. What I wanted to add is, again, it's not necessarily CVD related, but the improvements in instrumentation is very, very important to achieve the level of precision that we have today. So that's also one of the key developments.
Well, not really. I think it just was going on, and I also always had the intention to broaden the field of applications, going down with the temperature, going away from the inserts, which was and still is a good market, but it was quite narrow. And so I always looked, what can we do on steel, what can we do else? And I also was promoter of PVD, because I thought it's just too narrow for a company to live only on CVD. And this was not always appreciated by the top management. I said, well, CVD is great, we earn money, why should we go in this PVD technology? And they learned it the hard way, but fortunately we are also in this field today very successful.
Well, of course, exciting is that we push the technology every day more and more to be further developed. That's, we can say, every day here to work in this field for this company, it's kind of a different challenges, different approach. Sometimes we need to change the vision, but we still keep the future in front of us, and we would like, of course, to extend the capability of CVD for multiple, let's say, directions and multiple applications, and bring the technology to the next level.
Well, as Renato mentioned, that let's say the main market for CVD is cutting tools, and this market is not that big, which forces us to move in some more advanced applications. And also, Renato is the granddaddy of the technology, and he knows that we need to work in different applications. We cannot put all the eggs in one basket. So the direction that we take in Ionbond is we're trying to diversify, we're trying to bring and find another markets where these coatings would be an enabler. And we are pretty successful in that, finding applications in advanced manufacturing in industries like semiconductor industry or jet engines or even space plasma propulsion.
Well, it was a very simple coating, moderate temperature on stainless steel extrusion dies for ceramics, for the catalyst manufacturing. We had to coat more than 9,000 holes, the same coating thickness with a given profile. And this was a very successful application. We increased the lifetime of such a die from a factor of 10 or even more. And it was a good business for our customer. It was a good business for us in service coating, but also in equipment sales.
Still for CVD, the main markets are two markets, at least for our companies, that's clear, and components, of course, that's clear. But now the landscape has started to change. It has started to change more towards to energy sectors, more towards also even to medical applications in this case as well. And of course, with the technology, you can now create much more advanced materials, composite materials and stuff, which are growing in the last few years extremely. And that's where also the technology is also adjusting in such directions.
On the Ionbond side, what happened in the industry in the last 20 to 30 years is consolidation. So large cutting tools manufacturers, they acquired smaller ones, so there was a lot of consolidation. And it ended up with larger companies became larger, and it was more efficient for these companies to have the equipment in-house. We certainly shrunk the size of the market for services in terms of cutting tools. It was the benefit of Bernex, but for us that of course forced us to look elsewhere in again in different areas, not forgetting about cutting tools, forming tools. These are still the very good applications. We just had to offer some more advanced coating so that smaller cutting tools manufacturers would remain competitive. And of course the component markets, again it's anything that may need our coatings, as I mentioned, aerospace, semiconductor, medical, decorative applications, all of this is on our radar. Well, what we are trying to do, we are trying to, basically all developments on the markets are usually driven by either technology push or market pull. So technology push meaning that we develop something, then we offer to the market. Of course, we cannot be completely separated from the market, but that's based on our idea where we believe, the application can benefit. So we try to work on, again, with our colleagues from Bernex on developing newer, more advanced coatings for cutting tools, and again, we are pretty successful. Cutting tools are easier to test to make sure that the coating works, and our customers very welcome any new developments because it makes them more competitive. And we are pretty successful in terms of cutting tools, in terms of some coatings on forming tools as well. And of course, from the market pull perspective, we try to work with the components, and the components typically take much longer to be accepted as a solution. So therefore, projects on the components takes multiple years, but we are trying to be active in here. And I keep mentioning the main industries because we need advanced manufacturing for acceptance of these coatings, and we work a lot with aerospace, also with Bernex together, with multiple industries where advanced manufacturing is needed.
Yes, this is coming more and more, especially the sustainability, because nowadays it's very important that also the technology, let's say, consume less energy, is more energy efficient when we're talking about power, other resources. But we are looking also from sustainability from the other perspective point of view for, let's say, changing the chemistry, using more friendly chemistry, less byproducts, or handling the byproducts on a different way. And this will be even more and more, especially when we look also to manage also the carbon footprint of the entire technology, monitoring from the beginning to the end. And that's including not only the CVD processes, that's including also how we build the equipment so far. And that's very, very important, and it will become in the next 20, 30 years even more important. Of course, we cannot stop the digitalization, that's clear. Nowadays, we're looking to, let's say, operate the CVD machines with artificial intelligence. That's becoming more and more. We have a couple of projects where we're working on such a concept, and that's something that just it's market-driven, tendency-driven by how the people operating nowadays such, let's say, complex machines. We hear many times that CVD is an old technology, but all through the years we have been managed to bring the technology to the new level, to find new applications, to find new, let's say, challenges to solve with the good CVD coatings, and we don't see that we are at the end. So definitely in the next 20, 25 years will be another challenges, another applications, but also another, let's say, requirements from the coating in respect of quality.
Yes, well, it will not be my problem because I certainly will not be around in
Renato,
this time.
you never know.
You never know. That looks not like. But I think also it's difficult to me to say which sectors or so. But I think this company, as Risto mentioned, it's old technology. But this company acquired such big knowledge in this field, and they will be able to use this knowledge. If new things come up on the market, it will just be the task to jump in to see what can we offer with CVD. I mean, this it's not only wear protection, corrosion protection. There might be other applications coming up, that's for sure. And I think it's important that this knowledge remains in the company with these people which always bring this technology ahead.
Well, if I may chime in that, you know, old is not necessarily bad. We know that, right? So, this technology goes back to 19th century, so it's still around. It's the first technology that actually offered these capabilities of modifying coating surface. And you know, it's my belief that this technology is going to stay. It's going to advance, but it is just so good. It is, in many cases, it gives the results which are impossible to get by different technologies. For example, ID coatings, coatings on the inner diameters, that is only CVD possible by CVD. So, and I know that our colleagues in Bernex are working on applications which go beyond coating just solid substrates. It goes in the composites and various applications where CVD shines. So I'm pretty optimistic that, you know, God knows, Renato, maybe in 25 years we'll be still sitting here and you know, recalling our days in CVD. It may happen.
For sure.
Well, it was my professional life. It was really never boring, always challenging, quite a number of problems to solve, but this you learn to handle. But yeah, it was really a For me, it was a lucky situation that I somehow stepped into this technology without knowing really what it is, not having a plan or so. It just happened and it was exciting. Looking back is always better than being in the daily business, but overall it was a good time.
Well, CVD with one word is equilibrium. With other word is like for us lifestyle. So we also learning with the technology to manage our life in a way of equilibrium, not only from the, let's say, business perspective point of view, but also from our in general daily life. And that's something that is keeping us still motivating all the time, and we don't see the end of this, that's clear.
Well, I'm not sure how CVD changed my personality, that is a different story, but certainly in terms of profession, it happened so that I started at CVD. Again, on the technical side, I involved in PVD and PA-CVD, so I think I became a coating specialist, for better or for worse, it's difficult to say. And as we call as we say in Ionbond, we are surface engineers, and I'm proud to be one of these surface engineers, and CVD was the onset of this professional path.